Okay, this is an example from 4.5, and we're given this data for a test for a certain disease, and we assume one individual from the group is randomly selected. Find the probability of getting someone who tests negative given that he or she did not have the disease. Now you might think you need the formula, but because we were given this chart, you actually don't. This is more just testing you understand the idea of given. So I'm going to copy this table to the clipboard, and I'm going to put it here so that I can see it and make it easier to work back and forth. Now, what does this tell me? Okay, someone who tests negative, but what's my first thing? Given that he or she did not have the disease. So this is the people who didn't have the disease. No. So this, I'm going to sum this. This is C2 to C3. So 163 people don't have the disease. Now I want to know what's the probability of those 163 people that someone who tests negative. Well, that then here is this blue number, 142. 142 people tested negative. So my probability is 142, those people who test negative, and the 163 people who don't have the disease. So my probability then is 0.871, okay, because it said round to 3 decimal places. That's my answer. So you can see you don't actually need the formula here. You will work problems later with the formula, but in this one, it's more just that you understand that since we know that they did not have the disease, we're able not to look at this entire group of people, but rather just this no column. And so obviously our probability is higher for the negative because we know they didn't have the disease. And that's the idea of conditional probability. We already know one factor, so we've able to weed out a group and therefore give us a better probability of what we're looking for.